So the next presentation will be a special setup in the sense that we will have a dual presentation, so two presenters coming up. First presenter is Gert. I'm just waiting for my slide to come up. There we go. Gert van der Merlen. He obtained his master in electromechanical engineering at the Erasmus Hogeschool in Brussels, and he has been working for 16 years in the technical department at DEME on maintenance and repairs, where he's served in various roles, going from technical superintendent to vessel manager and then technical manager on projects around the globe. Last year he took up a position as project manager for the department in sustainability. He's working mostly on emission reduction projects and looking into relevant technologies for marine construction vessels operated by DEME. And then intermittently, if I understood correctly, we will have Bert Wouts also from DEME joining in on the presentation. He obtained a master in electromechanical engineering with a focus on maritime engineering from Ghent University back in 2015, after which he joined DEME and has been working there as a project engineer for new building. He's been closely involved in some LNG projects, the naming of the vessels you can see here, and he's investigating a range of sustainability topics. And with that, I think I first hand it over to Gert. Gert, off you go.
Thank you, Sebastian, and also thank you very much for this nice introduction and having us here today on this forum. During today's presentation, myself and my colleague Bert Wouts, as introduced by Sebastian, we will give you some insights from a vessel owner's perspective, especially on the use of methanol and how it can be an emission reduction contributor for an organization like ours. Before evaluating methanol and its role, mapping the challenges and evaluating the gaps and how to bridge them is obviously the first step we need to make. So in this presentation, we will give you a few of these key challenges, of which some common are shipping, and some are maybe more related to our specific industry of marine construction. Onwards, we will also briefly evaluate the position of methanol as an alternative fuel and its hurdles for integration into ocean-going vessels. But ocean-going vessels that we operate are also active in the field of maritime construction. When we talk about key challenges, in essence, we believe that for the implementation of a new alternative maritime fuel, we can bring it back to basically three domains where a new fuel has to perform or a certain performance test is required. Firstly, there is, sorry, I haven't shared my screen yet. So now you should be able to see my screen. Sorry about this. So to evaluate the key challenges, in essence, for implementation of new alternative maritime fuel, we believe we can bring it back to three domains in which any alternative fuel need to perform. Firstly, there is, of course, the domain of emissions and reduction strategies in which a new alternative fuel needs to fit in. Secondly, its performance in terms of policy, ongoing and future regulations. And lastly, a framework which is more like in the sense of technical and commercial aspects. It goes without saying that, of course, these three own domains have their specific parameters, that's one thing, but also have a high level of correlations and interactions. So making or introducing a new fuel is making it a very complex matter for a vessel owner. Before we step into DEME as a company, or let's say step into the topic of an alternative fuel, it's important to have a look on our own activities. Short, brief company introduction. DEME is a global player in 4 domains, active in dredging, offshore, environmental and marine infrastructure, And as the pictures on the slide already suggest, especially in the field of dredging and offshore, DEME owns and operates a large and diverse fleet of purpose-built vessels that obviously require power generation on board to execute their tasks at sea. Till date, obviously also, this power generation highly depends on combustion of fossil fuels, and emission comes with the combustion of fossil fuels like SOx, NOx, and particles, affecting human health and environment, but also CO2 and other greenhouse gases that contribute to the climate change. So DEME, as a company, already has taken certain steps to reduce their emission footprint and operates a large fleet already of dual fuel vessels that can operate on LNG. The key challenges, as highlighted already, we see it as three main domains of performance where a new alternative fuel has to comply with. First of all, there is the emissions. Secondly, the field of the policy frameworks, and eventually also technical and economical. Looking at DEME and its emissions, first challenge is, of course, to reduce greenhouse gas impact on climate change. DEME therefore has set two goal-based targets to reduce its greenhouse gas footprint. One is on the medium term, one is on the long term. The medium term, in line with the, let's say, the IMO benchmark relative to 2008, is to a reduction of 40%, and on the long term, to become a climate neutral organization in line with the European Union. As you can see on the left-hand slide, about 94% of our greenhouse gas emissions is related to combustion of fossil fuels on board of our floating equipment. And to achieve then eventually these targets, we can basically look at two drivers. One can be identified as fuel efficiency or fuel economy. The other one goes to alternative fuels. If you put that, let's say, some trends in an overall graph, also relevant for global shipping, and not really considering sensitivities such as the fleet occupation, absolute greenhouse gas emissions relative to the time since 2008 show an increasing trend. This trend is coming from the scale of economics, of course, and growing global fleets driven by economic growth and globalization. But nevertheless, when setting the 2008 benchmark, the business as usual curve here represented in yellow, the curve has somehow flattened out or relative to the growth and over the time by implementing efficiency technologies. If we do, or if we look more to the future and do some forecasting, represented in the blue and the light blue dotted line on the curve, you can see that the effect of efficiency technologies will continue to contribute in decarbonization of shipping. However, we believe that eventually the impact of energy efficiency will not be sufficient to reduce and eventually reach the targets. So as you can see on the graph, the gray arrows indicate the need for an alternative fuel to reach eventually these targets. In short, you can say that it is not a matter of if we need an alternative fuel, it's more a matter of how much alternative fuel we need to reach the target. The second key challenge, or where a new alternative fuel needs to perform, is obviously in the domain of policies, and especially in emission policies. Operating ocean-going vessels in coastal areas, regional areas, national and even local contexts like ports, environments can be therefore pretty challenging. If you go through all the different levels of the policies, obviously you have the big UN framework and its sustainable development goals in particular, SDG 7 and 13, about renewable energy and climate action. Two goals obviously closely related to each other. But the UN concept of localization has eventually placed these goals on the table of every policy making or policy-making organization, from a broader multinational level up to a subnational or even a local level. So if we look into these various levels, obviously the IMO, as a shipping organization, has placed already a lot of regulations towards local pollutants and local emission limits for NOx and SOx. And for the global shipping, by introducing greenhouse gas targets or CO2 target reduction targets, rather, they use very much these transport work parameters. As you can imagine, when we operate our vessels, they're mostly designed and built to stay in a steady position or work at a very low speed, and are also not really built to transport cargo. The meaningfulness of this specific proxy can be very challenging. On a more regional level, the EU and also China are setting their own targets with accompanying policies that affect activities in the maritime community. So common heard criticism there, which we can partially share, is that these regional policies are a bit unilateral, and a rather global or multilateral approach would be certainly beneficial. Further regional policies and legislations, also in a domain that we are active, is on rivers. The EU has placed the stage 5 for inland waterways and inland waterway vessels. Since we also operate in that domain, it can be challenging to also comply with these regulations. And then eventually, of course, ports also tend to set certain regulations. A common example is the use of scrubbers within a port area. When moving to the third category, or in which a new alternative fuel needs to perform for us as an operator, we can identify various specific hurdles. Some may be more common for the shipping, some specific for our fleet. As mentioned, our fleet consists out of a diverse range of purpose-built vessels. Purpose-built in the sense that both their design and power generation have been optimized in function of a specific activity. And it comes with power generation from combustion engines that range from maybe less than 100 kilowatt up to roughly 10 megawatt. Another specific feature, especially for the dredging fleet, is that these type of vessels have quite a large lifespan if compared to, for example, cargo vessels. Dredgers exceeding 30 years and even more are quite common, and this pushes the industry somehow to firstly thoroughly consider the design of new ships, but also to ensure, secondly, to the options and the potential for retrofitting in order to comply with all the regulations and the targets. Both approaches, new bit and retrofit, when looking into alternative fuel options like methanol, require a balancing between emission, technical, and economic feasibility. And for this, we have been doing already quite a few studies, impact studies, and also gap analysis. So it is with pleasure that I pass on the words to my dear colleague Bert to give some insights on these specific studies and gap analysis from a new build perspective. Bert, it's up to you.
Good morning, everybody. As you can see on the next slide, there are quite a few options for the climate neutral fuel of the future. There are a lot of fuel families, and each of them can be made based on a fossil basis or based on biomass or power to liquid. And it's, of course, the last categories that are of interest for the future. And in the next slides, I will discuss in more detail the case for methanol. So the main reason to apply methanol on our vessels would be to be able to consume power to liquid methanol. And this can be made using renewable electricity and carbon capture. But also an advantage is that we can consume biomethanol. This can be made from biogas or glycerol. This is let's say a waste product from biodiesel production. So there is a large variety of feedstocks available. Also, an advantage is that on the local pollutant side is that methanol is quite clean burning, so there is not too much local pollutants present in the exhaust stream. There are also some disadvantages of the case of methanol. So first off, there is no CO2 reduction when you would operate your vessel on fossil methanol. So right now, there is no immediate benefit. And also power-to-liquid methanol production remains in the pilot phase. And direct air capture of CO2, which will be discussed later, I think, in the afternoon, will be required to close the cycle by 2050. For now, there is plenty of concentrated CO2 sources available in the chemical industry, but this will not remain the case when the world shifts to climate neutral operation. Also, a point of attention, it's not a deal breaker, but methanol engines are known to emit formaldehyde and methanol slip emissions. So these are to be studied in further detail. So on the next slide, I will discuss some technical points with regards to the implementation of methanol. And again, the main reason, as already said by Sebastian earlier today, is that methanol is the most convenient way to transport and store renewable energy when we compare it to LNG, ammonia, and hydrogen. And we also see that vessel technology is becoming quite mature with a lot of experience in tankers. And it's a safe containment of the fuel. We don't have the cryogenic or toxic risks that are associated with other alternative fuels. We also see that engine technology can quickly mature. There are some real-life demonstrator cases, and there is some continuous R&D effort ongoing. We see, as a ship owner, for us, it's important that the dual fuel technology can enable us to future-proof our ships and still run our ships on the current fuel on board, the current available fuel. And lastly, methanol is quite feasible for retrofit. Also, there are some drawbacks for the methanol case. Let's consider, for example, the considerable deadweight impact caused by the quite heavy weight of the oxygen atom in the molecule. There is also some impact on the vessel layout and operational procedure because it's a low flash point fuel. Currently, there is not too much commercial availability of methanol engines. And also LNG, biofuels, ammonia and hydrogen, they can also be an attractive case for transitioning towards a climate neutral operation of our fleet. And lastly, there are some commercial matters to be discussed. So the main issue right now is that there is a very limited availability of climate neutral methanol. And when we can get it, it comes at a considerable additional cost compared to, let's say, fossil diesel. We will see that it probably will change in the future. So power-to-liquid methanol is a promising contender to decarbonize shipping. But it also means that at this point, we have to invest in technology for which the benefit is still uncertain. And in the next few slides, I will dig a little bit deeper on the actual implementation on board of methanol. So if you can skip to the next slide here. So methanol, we can store it at atmospheric pressure and ambient temperature in normal structural tanks with the zinc coating. Below the waterline, we can even store it adjacent to the water. We will need to maintain a nitrogen blanket on top of the fuel to make sure there is no explosive atmosphere in the tank. And yeah, we need to install cofferdams to avoid bringing the risk to other rooms in the vessel. On the engine side, we prefer to have dual fuel engines because it gives us a lot of operational flexibility. And it also means that there will be no loss of propulsion in case of a methanol leak. So this omits the requirement for a redundant fuel supply. And one of the challenges we have in our fleet is that we have a large variety of engine sizes. So on that side, we would benefit for a greater commercial availability of engines. On the next slide, we also have the case, the issue with methanol being a low flash point fuel. So at DEME, we have proven that the implementation of low flash point fuels is feasible. We have quite a lot of LNG powered vessels operating. And this is even possible for our purpose-built vessels, which are frankly said full of equipment. This also means that we will have some hazardous zones on deck, which will have some impact on operational procedures. And mainly the double wall pipelines in the engine room ensure that the engine room is gas safe and we can continue business as usual. We are quite happy that IMO will approved the draft IGF code in November. So this means that as a ship owner, we know the impact of methanol upfront. One of the elements that needs to be mentioned is that the hazardous zones do not scale with vessel size. So this requires a case-by-case approach. It's quite evident that a tank of, let's say, 1 cubic meter forms less hazard than a tank of 1,000 cubic meters. And an important part of the IGF code is that risk assessment forms a essential part of the design. So before starting construction, all parties should be involved and tackle the hazards at an early stage of the design. So that was my part of the presentation.
Thanks, Bert, for your contribution. Maybe as a closing and the takeaway for this presentation from an owner, we can conclude that there are a few specific challenges, especially for an operator like DEME. They are situated in the field of the emissions, as already highlighted previously and as highlighted by Bert. Methanol has to come from hydrogen, and there is also renewable hydrogen rather, and the topic about CO2. After all, methanol is still a carbon-containing fuel. Towards the policies, there is still significant work outstanding, but also synergies are needed. So to make sure that we can all stay in line and comply with all the legislations. And on the technical field, technical development, certified marine engines, covering a broad spectrum, preferably 4-stroke of power ranges. And maybe not that yet specifically highlighted, it's only briefly touched in this presentation, is the availability of the fuel itself. So the entire supply chain going from producer through bunkering all the way up to the vessel. Long story short, the gaps for the methanol case are pretty diverse, specific, and complex. So it speaks for itself that for bridging them, bringing together key partners and key resources is essential, and we definitely are thankful to the Fastwater in their team to organize such forums to bring all these key resources together. I don't know. I see we're running slightly over time, Sebastian. If there is still a bit of time for questions.
Okay. Thank you, Gert and Bert. Given timing, indeed, I would suggest that we hold on to the questions targeted at you, and we pick them up at the Q&A after the final presentation.